I wasn't going to do this, but I think it's in spirit with the day. So I've got a 2-year-old daughter, and this is a little lullaby I sometimes sing to her at night. JavaScript is falling down, falling down, falling down. JavaScript is falling down, my fair lady. Build it up with JSLint, JSHint, ESLint, underscore, low dash, npm, bower. Then we need React, Flux. There are 4 different module systems, I think, and there's a new one coming. We'll need Babel, TypeScript. Oh God, and there are others, my fair lady. No. I've been having lots of adventures in user interfaces for the past few years. I think it's it's an interesting world to me. Whenever I think about this, I start thinking back contextually, all the way back to 1995, when if you were lucky, you would get 5 free email addresses when you signed up for an AOL account. 5! Think of the power. Those were the days. This language came along called JavaScript, which at the time we thought it was for doing pop-up boxes that said, "Don't leave my site," and occasionally kind of form effects, like when you hover over a link, it will twiddle. And it was great. That's all we ever needed. It was this brilliant scripting language for doing stuff that didn't matter. And no, nothing much happened until this is a perfect picture of 2001. On the left, you can see the ocean of cash, which represents the Y2K problem. And then to the right, there's the ocean of cash, which represents the dot-com boom. We move forward into the time of jQuery. Right, and jQuery was, you can see it different ways, but really at the time it was about turning JavaScript into a single platform so that you could reliably write something that would work on every single browser. Modulo Internet Explorer. And we also started to get some kind of reasonable presentation with CSS. Gradually, things were evolving. But I think what really, this is almost a decade where not much happened, but it kind of standardizes, right? And then you reach this point in about 2006, 2007, when 2 things I remember absolutely exploded in the front end. The first was Gmail, which was the first mainstream look at the things we can do in the browser. Look at what we can do in this crazy new world that people are exploring. And the other big thing that happened was Doug Crockford's book, JavaScript, The Good Parts. This is the turning point for me. We suddenly realized we could build rich front ends, and we had permission to use this strange little language that wasn't just for pop-up boxes anymore. Time has not been kind to this point. In fact, there's a new edition of JavaScript, The Good Parts coming out next, I think it's next spring, and it's going to have this cover. Why is that? Because, yeah, so our expectations are growing. We've got one other thing before I'm going to say that time has not been good. The last big innovation in that period for me was Angular, which was a very high-quality implementation of the wrong way to build websites. But it was very interesting because it was the first time, I think, when we started to get away from low-level DOM manipulation into let's start thinking about building apps that take care of that sort of nitty-gritty for us. Angular, I remember, as being the turning point when we walked away from jQuery and the very low-level stuff. Where's Hocken? The very low-level stuff, like jQuery. into this world where we started to try and not think too much about the browser and just think about building applications. The big problem we face on the web is in that whole period from 95 up to now, our expectations have just grown. Gmail started a rocket in the front end where everybody was thinking, how much further can we take things? Our users started to demand more. There was kind of an arms race of expectations from the user. In the meantime, the technology we've had to implement that has not really grown much at all. The base strata of the front end, JavaScript, is not keeping pace with modern expectations. But I have hope. I have lots of hope. I have depression, and I have hope. I have depression because JavaScript I don't think is adequate anymore. I think in JavaScript we got something much better than we needed at the time, but not nearly good enough for today. And it's a shame because front-end programming is huge fun if it wasn't such a flipping misery. But I have hope, and there's a kind of wave of new things coming along which give me hope, and this is the point of my talk. Quick Oscar Wilde quote: "A map of the world that does not include utopia is not even worth glancing at." We have to hope. We have to look forward to something better than what we've got. Sorry, Portia, I wrote this slide before I saw your... So let me talk about the hopes I have for saner languages. Oh, hang on, I tell you what I'm going to do, if I may, quickly. This is the point where I wanted to unmirror. Why is that not working? Sorry, 1 second. If I do that, and then, hopefully, you will get that. No? Oh, hang on. I shouldn't do this in the middle of a talk. I take it back. I'll just live. I'll cope. You'll cope. We'll all cope. Yep. Scale. Nope. Sorry. I shouldn't have done that. That was a mistake. It's all going flawlessly. I blame the Wi-Fi. Where we are today is, I think it's a very exciting time. We're finally starting to get a new flush of languages for the browser. We can build new, interesting things. And they're interesting for a couple of reasons. Firstly, they've been given time to mature. You see this particularly in something like ClojureScript and the celebration of hammock time to actually design a language before it's released. And there are a few languages like this coming forwards. The other is, we've had languages that try to bypass JavaScript before, but they've always been about avoiding JavaScript, I think. Particularly the stuff that's come out of Google in around 2006 until a few years back was always characterized by trying not to write JavaScript, which is a good aim, but it's not a good design principle. You end up with something that's built on avoidance. We have a few languages coming up right now, and I'm thinking of ClojureScript, I'm thinking of Elm, PureScript, and a few others that are actually about, this is a domain we want to be in. The front end is an exciting domain, but we have to build with better tools. So let's take some good ideas and some good tools and put them in this new world, rather than let's reluctantly go into this world and try to run straight back. Hang on. Yeah. And the other thing I have hope for is better design. So not only are we bringing better languages into the front end, we're also bringing new architectures, better ways of thinking about user interfaces that perhaps we haven't even done on the back end before. Some of the stuff, I don't want to steal from Martin's talk, which he's given later. He's going to talk about this in a lot more detail, but I kind of want to tell you my favorite features of new languages coming up, and then my favorite features of the architectures which are coming about. So the first big idea, I think, is as a room full of functional programmers, you'll appreciate this. The biggest idea in programming is data. That's where it begins. Data and data modeling are the biggest ideas in programming to me. Because everything we deal with is about representing facts and then dealing with those facts. And I sort of feel I shouldn't need to say this, but it's, we've been through a period in our history where it seemed almost naughty to separate data from the processes that use it. And I'm thinking of Java and OO. There is a religious need to not trying to avoid using that word. Robert at the back will sneer at me. To tightly couple data and transformations. When you pull those apart, you can start thinking about data and facts in the world, and then take a look at dealing with those and processing those. Let me give you a concrete example, because that's a very abstract thing to say. Okay, so what I'm going to tell you is one feature I think is very important in programming languages. In fact, I would almost give it my definition of modern programming language is, does it have a way of talking about data? Does it have a way of describing data succinctly in a lightweight fashion? I actually think that's one of the most important things you can get in a programming language these days. Here we go. Is that good? Okay. So this is an example of Elm, and this is the bit I want to point you to. Imagine you've got, imagine you're going off to Wikipedia and running a Wikipedia search. I want to describe that by saying a response from Wikipedia is one of two things. It's either an answer, which will contain the title of the article I'm looking for and the body of it, or maybe they'll come back and say to me that search string matches several possibilities. Even if you don't read Elm, you can probably see how that description matches what I just said. Right? There's a very concise way of describing the possibilities you can get back from a call. And when I compare that with something like Java, it's actually very hard to just describe data in isolation. You get this with closure in spec more than in raw closure. I guess that counts as core closure these days. But it's really characteristic of languages like Haskell and Elm. And when you have that, you can do interesting things like, let me show you this. So where are we? Make that a bit larger. There we go. Can you see that? Yeah. So just to give you a flavor of the code, this is... hang on. I've just figured out why the mic's going on. This is a function that would take one of those responses, look at it, see what's going on, and print out a relevant piece of HTML. Even if you don't read Elm, you can probably see how that's working. Enough people are nodding that I think you agree. Yeah. So that's a very cool thing. For some languages, you can get a very nice feature as well with that. You could say, OK, now I'm going to update my description of what counts as an answer from Wikipedia with, you might get an error code, right? So an error code usually has an HTTP status number and a string. And you can get a nice feature like this, which is where it can now tell, the compiler can tell that because there's an extra part to this description of what can come back, it can see all the places in your code where you haven't allowed for this extra description, right? Make that a bit larger. Yeah, there you go. You can see this code is telling me that this data type has an error, but I haven't handled it. And that's a really nice feature when your language has a good way of describing data and has a good way of realizing some of the implications for you. That's a very nice programming feature. If you imagine that these two functions weren't in the same file, but were across several directories, maybe in a submodule you'd never written, your colleague had written, that's when this kind of feature becomes very, very nice. That kind of stuff is that kind of data description language, a lightweight data description language, is something that's coming from academia. I think. Academic computing has known about this for a couple of decades. I think it's just starting to come mainstream in our industry. So we should go to academia, listen to what they have to say. It's a place in Knox, which is near Fort Knox, apparently. This is totally random. I looked up this for the slide, and it turns out right next to Academia Knox is a job centre called Opportunity Knox. Totally irrelevant to the presentation, but you can't miss a pun like that. And the other big idea, which again doesn't seem like a big idea unless you've lost it in the Java mind, is the idea that once you've got data descriptions, then your job is almost done once you have ways of transforming those descriptions from one form to another. Half of what we do is figure out how to represent the world as data, as facts about its current state. And the other half is figuring out how to change it to new states of the world. So those are the two big ideas, I think. Data and functions, which you might call functional programming. There's a bit more to functional programming than that, but I think if we've got those two things, we haven't lost sight of where we're going. There's another feature I like coming up in some of these languages, which I find incredibly useful, which is sort of related to the data description stuff, is how when you have a good data description, it can illuminate some of your design choices. I'm going to show you a quick example of that. If I make that a bit larger. Can you see that? Yeah. So if you've ever used Bootstrap, you can probably guess what this does. This is going to take the name of an icon in Bootstrap and generate the CSS class you need. Very, very simple function. What I like about this is having a language where the structure of the structure of the function is separate from the body of it, where you can read independently what it means without reading how it's implemented. And that's a very nice analysis tool, because you can start to say to yourself, is the correct implementation, never mind the code, is the correct implementation of this thing that generates an icon really takes a string and returns a string? That seems very loose to me, once you start to look at the shape of it without the details. So this is saying that this icon function should be able to take some total garbage from Donald Trump's speech or something and return something meaningful. Really, this should be much more tightly constrained, and it would be if we had a good way of describing the data that's allowed to go in. For instance, what if we change the type signature to takes an icon, and we can define what an icon is? We can limit it to the valid set of possibilities. And then we can change our function not from string to string, which is about the most generic function I can think of, to something specific and illuminating. This takes an icon, which can only be one of these three things, and will return HTML. I find the ability to be that precise on a more abstract level than code implementation is a very exciting idea. And the next part, and I'm going to do some code demos in a minute, but the next part is functional architecture, which again you're seeing coming up in ClojureScript. I think Elm is really the poster child at the moment for functional architecture, because it's pretty much all it does. It's a language with a particular opinion about how to build websites baked in. But I've written code this way in ClojureScript, and I plan to, once conference season is over, do this in PureScript. The idea is very portable, so don't think I'm selling you on Elm. I'm selling you on Elm. Don't think I am. It's an idea you can take wherever you're going, but there are places that are very richly supportive of this idea, which is you can pretty much describe every single web application you write as things happen, you get events in, and you get your current state of the world, your description of the facts you know about the world, run a function over it, and you'll get a new state of the world. And possibly some things you need to go and cause, like AJAX requests. And then one other function which takes the new state of the world and turns it into HTML. If you don't need that, this is a pure function from data to data. And this is a pure function from data to data. This is really the only complication because it's a side effect, and side effects are always complications. You could almost boil down Elm's architecture and port it across if you remember these bits. A function from data to data, tongue twisters. A function of data and data to data and maybe some tasks, and a function of data to more data, the world to HTML. It's really that simple, and it works really nicely. I'm going to try and show you some examples, hopefully persuade you of that. Because I've rambled too long without you seeing Emacs. I know some of you are getting withdrawal symptoms. So, I wanted to show you. Can everyone read that? Yeah, good. Okay. So, if I show you. Let me make that a bit larger. So this is a registration form, right? You've seen a million of these. Let's go email address, password, hat size is 34. My firstborn child's name was Ada, of course. Gender box, you have to have one of those or it's not a registration form. Register, right? What's happening under the hood there is every time I type, there's an input. There's an event saying something has changed. I'm saying set email with this new value, right? And it changes our state of the world, this internal model. So you can see that updating. And then we take that model of the world and we render it out to the screen. It's just a function from that data structure at the top into HTML. And it's as complicated as HTML is, but no more. Excuse me. But it's very simple. Events change your state of the world. Your state of the world gets rendered to the screen. You don't actually need more than that simple model to start building interactive websites. And as a kind of illustration of that, once you've got that model of the world, you can do other things with it. It's just data. You can run other functions on it. So you could take that data model and say, run a function that scores how complete this form is. Right? We get a progress bar easily because it's just a function from data to a number. And we can add in things like, well, that's just a percentage, so that can be, yeah, there we go. Are we almost complete? And we can register, right? What have I missed out? I've missed out something, I don't mind. Yeah, there we go. And now I can register. What's the point of that? It's a function from data to an int. Instead of being a function from data to HTML, it's a function from data to an integer. And we can do other things with it, all on the same model. So, another example of that, let me show you this. Is it there? I hope it's there. Ah, it's there. There we go. This is another example of exactly the same idea. Right? This time the mouse pointer is an event. It's data. It changes our state of the world. We're keeping track of where that pointer is. And we just have to do it's a much more complicated function, but it's the same architecture. A function from where is the mouse in this room to what shapes should we print to the screen. And you get this kind of cool light tracker thing. Most of this is geometry, but the architecture is exactly the same as a registration form. So the meaty thing I wanted to show you, and we'll have to see if the Wi-Fi is going to work here. I would appreciate it if anyone can connect to seats.clearacode.com. And for this interactive portion, you're going to want to know your seat number. So you are row A, B, C, D, E, F, G, H. You are seat 1, 2, 3, 4, 5, 6, 7, 8, 16 at the far end. You're all intelligent people. You can figure out your position. Meanwhile, I'm going to see if this works. Let's see if we can get anyone connected here. Oh, it's... Oh, hang on. One second. Oh, we've got a couple of people connecting. Carl, well done. Love you, man. James Henderson. Anybody I don't already know, can you try and connect? Richard Lewis Jones. Where are you? Rich, I should know where you are. This is the whole point of this, except I'm stage reversed. Hang on. Corny, you're there. Somebody at the back over there. Joshua? Yes? Okay, it's all coming in. Live audience participation. John, thank you. Let's see. Any more? Okay. So you may have noticed, if you've managed to connect, there's a box to ask a question. Has anyone done that? Someone's asked a question. Okay. But I can't tell who. So here comes the live coding portion of the evening. Okay. Let's do that, and then I'll tell you how this is built up. Okay, a few of you are starting to connect. This is good. So, what I would like to do is, I've got the data of your question in the system, and I thought I'd just show you how I can change the function that turns that data into HTML so that we can actually see what's going on live. So, if I go here, this is a function that takes, you'll see in a minute what an active seat is. If I click on a seat, you can see the name comes up, right? That's the active seat. So I've got a function that takes a possibly active seat, because there might not be one, the occupant of that seat, which will have your name and your row number, and it might return some SVG to render out your seat on the canvas, right? So, I'm going to change this so that when we draw out the seat, if your question is nothing, if you have no question, yeah. Should we do that? Yeah. If you have no question, then stay dark green. Otherwise, change it red, right? Easy function. Let's compile that, and we should see there's no such variable as question. All right, not terribly interesting. I can fix that. Let's try and get a more interesting error message. If I compile that. Oh, it's a deliberate typo. Does it the other way around, though, which is interesting. I wasn't expecting that. So it's saying, I can't find question. Did you maybe mean Q session? But it's interesting that it's giving you that support, right? And I pretty easily tracked down which one of those was right and which one of them was wrong. But I can now see why there's confusion. So let's fix that. And okay, should we do anything else? So if you have a question, you should show up red now. Let's have a look at that. We'll reload that on my end. Why is it not working, Jim? If your question is nothing, then dark. Has someone saved a question, right? Somebody saved a question, yeah. Oh, God. High wire. I'm a fool. Okay, let me try it this way. Sorry, I've forgotten that your question sometimes will be an empty string, which isn't helpful. If it's that, let's try it that way. Oh, no, I know why that wasn't. Sorry. Wrong make command, that's why. There we go. Sorry about that. This will work. Yeah, okay, most of you have a question. Good. Live coding on stage is fun. So, Susan Wilcox has a burning question. We still don't know what it is, so let's change that part. So, I will go to here. and say, I know this is the bit where we're taking the occupant of a seat and rendering out their name at the top. All right, so let's add in a quick block quote. Everyone see that? I just want to give you a flavor of playing around with this. So I'm going to render out the occupant's question there. Yeah. And we get this error, which, now this is a really interesting error in a way. Depends which languages you use. This is saying, I've tried to render the question out as a string. Yeah, I'm trying to call the block quote with the text of the occupant's question. But they may not have a question. The form allows for you not having written a question down. So the question is optional. Hang on, I want to explain this in a way that doesn't just explain it to the people that already know the answer. Which would be nice, wouldn't it? Take a language like Java, right? You take an integer in Java or a string in Java, it's not true, it's a lie. Every string in Java is a string or null pointer. Right? Every integer in Java is an integer or a null pointer. And null pointer exceptions are the single largest cause of errors in Java, certainly in JavaScript, probably in most languages that allow them. And this is a solved problem. This is one of the other things that happened 20 years ago in academia, which is brand new in our world, right? The ability to say, a string is just a string, unless you tell me otherwise, unless you say, this can sometimes be null. And that's what I've done here. That's what a maybe is saying. It's saying, by default, a string must be a string. If you want the behavior of null, for some reason, you have to add it in. And then just like we saw with the Wikipedia error example, you have to account for it. The compiler won't let you off. This eliminates a huge class of errors. Let's go and fix it the same way we have up here. We'll just say, we'll just do a match on it. Have a look at the occupant's question. If it's nothing, if it's the null case, then don't show anything. Otherwise, if it's just a question, then we can show it. Right? Make sure that compiles right. Here we go. Now we should have something. Now we'll try and go back to Susan Wilcox, because she thought she'd won. Yes! Okay. So now we can seamlessly segue into the Q&A segment. You can resave your form if you decide you want to change your question. I'll just let you know that. Oh, I was going to, yeah. I'll tell you the architecture of this in a second. Let me answer at least this first question. Is Elm better than ClojureScript? And if so, why? No, because I'm at a Clojure conference. No, the biggest idea for me is, do you have a well-designed language? Right? Is your language well put together? Has it been thrown together in 2 weeks, as my least favorite language was? Or has it had some time to mature and some design principles behind it? So that puts Elm and ClojureScript in the same category. The next biggest idea for me is the idea of functional programming, right? The idea of describing data, describing transformations on data, and minimizing side effects. And that puts both these languages again in the same basket. I think they're both great. I think they're both very good choices and much better choices than the default front end. Having said that, and you will hear this more vehemently from Martin Troyer later, I do quite like static typing. It does if it's done well, it catches a lot of problems. I think it's the icing on a very nice cake. That's my answer. Should we have one more for now? Oh, yeah, watch time. How long have I got? None of time. I'm out of time. Okay, one more question. I'll post the source code. You can explore it. Maybe you want one of the following question. Right. Thanks, Nick. What is to find the Grail, Neil? What's the Wi-Fi password? What's wrong with Elm? Okay, that's a good question. It's evolving cautiously, which is a good thing and a bad one. What smells? Java. Do one more. Oh yeah, a real live question from someone that doesn't have Wi-Fi.
It looks a lot like it's Haskell with a bit of architecture. Is that great design paradigm?
Yeah, I would possibly describe it as Haskell made accessible to the mainstream. If you're thinking of learning Haskell and scared by the learning curve, Elm would be an excellent way to get started on it, because it will introduce a lot of the concepts, but not all of them at once. Okay, and I think I should cut it there. Thank you very much.